OK, one last case study before we're done with TLS is to think about the certificate step and how you actually implement that in real life. So as a quick reminder of the relevant step in the TLS handshake, remember that in the second step, after the hellos are exchanged, the server has to send its certificate. And remember that a certificate is a weird name for the server's public key signed by someone you trust. So it's got this fancy name, but it really is just someone's public key signed by somebody that you trust. Now, when we talked about TLS, theoretically, we just said the certificate is signed by a third party that we trust. But in real life, who is that third party? Who is the other person that you trust when you're connecting to websites? So now that we're thinking about real-life implementation, we have to start thinking about business incentives and what kinds of organizations we trust in real life and what organizations we don't trust. So we're moving from theory into actual real-life implementation with all of its business implications. So the browser has to verify the certificate by verifying the signature using this third party's public key. But who is the third party? Who is that certificate authority that helps us make sure that the server is giving their honest public key and not lying and giving the attacker's public key instead? How do you achieve this in real life? So first, we'll go through some problems that might occur. One problem is if the third party isn't trustworthy. What if the server sends a certificate and it says, here's my public key, and it's signed by Joe? OK, who is Joe? I don't know. You don't know. We don't know who the third party is that signed the certificate. So what browsers will do in that case is they'll show you this warning. And maybe you've seen this warning before when you tried to visit a website and it's improperly configured. One possible reason that this warning pops up is because the server sent a certificate in TLS. It's signed by a third party, but you have no idea who the third party is. Do I trust them? Do I not trust them? I don't know. So you get this warning, and the user has to deal with it. And remember, we talked about human factors. If someone doesn't know about TLS, they probably have no idea how to read this message. So something else that browsers have to do is try and communicate to users what the problem is. You and I now know that the problem is that the certificate is signed by someone we don't necessarily trust. Users probably don't know that, and browsers have a challenge of communicating that to users. So hopefully, the user stops connecting if they're afraid of the security implications. What if the user decides to connect anyway? They ignore the warning, and they say, I really want to visit this website, and I don't know if the certificate is trustworthy, but I visit it anyway. What happens in that case? Well, now you have no idea who the public key belongs to. This could be the attacker's public key signed by someone you don't trust. So you don't know who you're talking to. You could now be talking to an impersonator who gave their own bogus certificate that said, I'm Google, even though they're not. So you've lost end-to-end security. An attacker can impersonate the server. They could also read or modify messages that you send. So that's why browsers have to show you this warning, because if you choose to visit the website anyway, you've lost potential TLS security. Now, if the TLS connection does go through, you might be curious to see what the certificate actually looks like. Now, I'm guessing most users don't do this, but if you're ever very bored, you could actually go into your browser and see the certificate in action, which is kind of cool. So at least on latest versions of Firefox or Chrome or something, you can click here. It says the connection is secure. So you click on that. It tells you that the certificate is valid. And now you know what that means. It means that whoever cs161.org is, they sent their public key signed by someone trustworthy. And if you want to see the certificate, you can actually click this. And it opens up the certificate. And we can see a bunch of stuff about the certificate itself. So for example, here are the bits of the certificate. I know it's kind of small, but it tells us that's the certificate. Here's the public key of cs161.org. And here's when the certificate was issued. Here's when the certificate expires, and we'd have to get a new one. And here's the name of who issued the certificate. It was issued by some organization called Let's Encrypt, and it was issued to cs161.org. So it's kind of cool that you can actually see the certificates in action in your browser if you are curious or bored.